Hey everyone, let everyone start to come in and I will start in just a moment. Okay, starting to get people in here. It's great. Okay. Hi, welcome to the webinar. We're going to give people just a few more minutes and then I'll get started. Thanks for joining us today. Okay, I think we'll get started. So we have plenty of time for questions. Hello, everyone. Let me start with just a bit of housekeeping. We will be posting the slides for this webinar and the recording of this webinar on our website and on our YouTube page. So if you'd like to go back and see something again, or if you'd like to share this webinar with a colleague, we'd welcome you to do so. We will have that up shortly. Also letting you know that all attendees have been automatically muted, and we're going to keep you muted this way for the entire webinar. Of course, we want you to be able to interact with us, and so for this webinar, we will be using the question pane. You will see the question pane located at the top right of the screen. You'll notice a speech bubble with a question mark inside. It's underlined here in green. This is distinct from the chat pane, which has a two-layered speech bubble. I will only be using the question pane today, not the chat pane, so please direct questions there. We will be answering your questions throughout the webinar if we can, and we won't pause the presentation to answer them live. However, we'll allot time near the end of the webinar to answer a live Q&A, and we'll choose some of the questions we've received. So please keep your questions coming throughout the webinar so that we know what's most relevant for you. Thanks. And for those of you who have been joining us or are joining us for the first time, we are a nonprofit organization based out of Medford, Massachusetts, and we have a mission to reduce energy, carbon, and light pollution. We do this by providing the right information on lighting and controls to decision makers. And one of the main ways that we do that is by creating technical requirements that support the majority of incentive programs across the US and Canada. My name is Leora Radetsky, and I am DLC's Senior Lighting Scientist. I am also the LUNA Program Director, and my colleague Andrew Antares is joining us today as well. He'll be helping me with Q&A today, so if you get a question during the webinar, an answer during the webinar, that'll be Andrew answering your question as I'm going. And of course, thank you to Lauren for helping us facilitate the webinar as well. So here's our agenda. We'll start by reviewing the mechanisms by which electric light at night disrupts sea turtle behaviors, and then we'll go into the DLC's technical requirements for turtle lighting luminaires. We'll finish up by looking at a demo of the QPL at a turtle lighting product that's currently listed. We'll review the testing requirements and the application requirements, and then end with a Q&A. So thank you again for being here. All right, so let's begin by looking at how electric light at night disrupts sea turtle behavior. Thanks to conservation efforts, we are thrilled to see that many sea turtle populations across the globe are rebounding. In the US, sea turtles are protected by the Endangered Species Act. However, impacts from climate change and conflicts with human populations continue to occur. In particular, I'm going to highlight the impact that rising seas have on available nesting beaches, driving sea turtles to nest in other localities where humans are present. This is seen, for example, in Hawaii, where rising seas and erosion on the northwestern Hawaiian Islands is causing Hawaiian green sea turtles to nest on the main islands like Oahu. Human-caused threats to sea turtles include coastal development, light pollution, vessel strikes, bycatch, and predation caused by human activity. When we talk about sea turtle impacts, we understand that the mechanisms that attracts them to light is pretty straightforward. Adult females are disrupted by electric light at night during nesting. Hatchlings typically orient towards the brightest horizon cues so they can quickly crawl to the ocean and swim offshore. This is known as sea finding. But electric lighting at night can compete with or overwhelm these natural seaward cues. The practical consequence we see then is disorientation or misorientation, where hatchlings are moving inland or they're running around in circles instead of toward the ocean, with associated mortality outcomes including exhaustion, predation, dehydration, and being run over. Sea turtle hatchlings also demonstrate increased spectral sensitivity and behavioral attraction to blue and violet light, and behavioral avoidance around amber and red light. Despite the evidence that light trespass onto beaches disrupts sea turtle behavior, management in coastal communities remains inconsistent and confusing for stakeholders. Coastal jurisdictions may have multiple sources of guidance. Some jurisdictions have none at all. And without consistent processes, each stakeholder in the lighting specification chain could have different definitions of compliance, make different product choices, and the resulting outcomes are inconsistent field conditions. For example, a lighting specifier and a sales agent might really need a compliance checklist to use of what matters most, and in the absence of one, maybe making best guesses about spectral and light level decisions. Lighting specifiers are likely not experts in turtle lighting requirements, to be honest, but no one wants to see baby sea turtles in public bathrooms or in the roadway. So the problem we see is the absence of a shared enforceable technical definition of what good coastal lighting looks like for sea turtle conservation. Now, we do know that many jurisdictions across the mainland United States have ordinances that address sea turtle nesting habitat. Most of these are located in Florida, and many use the Florida Wildlife Commission's wildlife lighting criteria or require the use of long wavelength light sources. This is not always the case, though. Some jurisdictions allow low CCT products or so-called bug lamps that have a yellow coating. A few ordinances have no spectral requirements at all and only require shielding of some type. And if we look at Hawaii specifically, in contrast, we see that there are no turtle lighting protection in this state, nor any county statute that addresses sea turtle protection at this time. A recent experience in Hawaii illustrates what happens when decisions are made with an incomplete understanding of what drives hatchling disorientation. So in 2023 on Oahu, Hawaiian green turtle hatchlings from 8 nests were misoriented at a popular beach called Sandy Beach after a 3000K LED retrofit. The retrofit changed the nighttime luminous environment in a way that directly affected hatchling behavior. After nesting activity was observed in 2023, the LED fixtures were turned off and then wholly replaced with amber LED fixtures. And this was a good attempt to correct what was perceived as the primary problem, where white light replaced these HPS luminaires that were there previously. Now, this is pretty common, right? White light is the issue. They substituted amber LEDs as the fix, but other changes were not taken into account. So necessary changes in illumination and distribution were not made. And as you can see in the fourth photo, light was still spilling onto the beach after the amber retrofit, necessitating that custom LED shields were added after the fact. Switching to these amber LED fixtures with shields addressed the spectral requirement and some of the light trespass issues, but they did not resolve all of the risk drivers that determine the actual field conditions on the beach. In this case, we continue to see some continued over-illumination, and we see wall-mounted lighting on the bathrooms that is not shielded at all, and this continues to contribute to the risk of hatchling misorientation. Even with amber light sources, if the installation produces substantial beachward spill, if it produces high-angle emission, driving light onto the beach, or excessive overall light output, the beach environment still remains artificially bright in exactly the visual geometry that affects disorientation and misorientation. So although there have been no confirmed nests in subsequent years since the retrofit, the lighting there now is still not benign. The risk mechanisms for disorientation still exist on this beach. And so I want to highlight this takeaway that spectrum substitution alone can create a false sense of resolution. It can satisfy this checklist requirement that we address the spectrum, but we really are still leaving the underlying exposure pathways intact. And so this brings us to a policy gap. The distance between ecological research that shows us what turtles need, lighting technology, and enforceable practice. And we know that the failures we see in the field are not due to malice, they're not due to indifference. They arise because the policies and procurements do not provide a complete set of constraints for the installers that cover the major drivers of habitat exposure. So what does this mean? Well, if an ordinance says use amber, for example, use amber LEDs, then procurement tends to buy amber products, and installation may proceed with standard output packages, standard luminous intensity distributions, and standard aiming practices and orientation practices that are perfectly acceptable for roadway performance and parking lot performance, but are not acceptable for a beach adjacent sensitive habitat. And once the equipment is installed, plan reviewers and inspectors may have no clear basis to verify compliance beyond the label amber. And that's how we see well-intentioned retrofits yielding overlighting and spill onto beach sides. So we need requirements that are explicit enough to be specified, procured, installed, and reviewed consistently across jurisdictions. And as I mentioned before, this recurring pattern we see of an over-reliance on spectrum-based guidance often implicitly assumes that if short wavelength content is minimized, then all of the impacts are mitigated, right? Just use amber. But ecological exposure is not determined by spectrum alone. Even these direct emission amber LEDs can be problematic if the light sources are visible from the shoreline where the nests are, if the lights are too bright, if the lights are poorly aimed, if they're distributed in a way that substantial illumination is delivered onto the beach or the dunes or any near horizon field that hatchlands use for orientation. And so to complete the spec, what we need is a more accurate characteristic of light that has an impact, including intensity, how much light reaches the habitat, the directionality and high angle emission, whether light is visible from the beach and at high angles, the distribution and spill, whether the light source pushes the light beachward, its controllability, whether the light can be dimmed, if there's curfew and operational constraints that reduce exposure during sensitive periods, and finally, installability. Are there shields available? Are there tilt limits? Are there procurement requirements that can be actually verified? And so outdoor lighting remains one of the most persistent and solvable drivers of conflict in developed coastal areas that contain sea turtle nesting habitat. And to close the conversation, to begin with, long wavelength spectra are necessary, but on their own are not sufficient. What matters ecologically is light that actually reaches the sensitive environment and that is visible from the beach. Its spectrum, its intensity, its distribution, and whether or not it's controllable and installable in a way that limits spill light. So to address this gap, we've developed a turtle lighting specification within our Luna version 2.0 requirements that translates the scientific understanding into a consistent policy-ready framework that communities can adopt through ordinances, permits, and procurement standards. And if you're not familiar with Luna, Luna stands for Light Usage for Night Applications, and it is our night sky friendly spec. So let's begin by looking at the baseline requirements for amber LEDs in our SSL version 6.0 requirements. This is for all amber products, whether or not they are turtle lighting products. Narrowband amber LEDs minimize short wavelength content that disorients sea turtles, but they are among the least energy efficient options. This means that municipalities face difficult decisions among ecological protection, energy efficiency goals, and costs, especially in inland and coastal contexts where budgets and maintenance capacities and supply chains are constrained. This is exactly where a robust specification can help. Rather than framing the decision as choose turtle safe lighting or choose energy efficient lighting, the goal is to define turtle lighting that is energy efficient relative to what is available in that constrained spectral category. and to prevent solutions that overlight the project areas, therefore wasting energy and creating more light than is desired. So energy efficiency is still part of the requirement set, but it's integrated into the ecological performance and not substituted for that performance. So as we look at the requirements, we'll start with efficacy. Efficacy is specified in lumens per watt, and for narrowband amber or direct emission amber LEDs, the requirement from DLC is 30 lumens per watt as a minimum. So all listed luminaires will have this efficacy or higher. We also want to make sure that the power quality is good for these products. So we continue to have power quality requirements for amber LEDs, just as we have for white LEDs, with a total harmonic distortion requirement of 20% or less and a power factor requirement of 90% or higher nominally. As I mentioned before, we're looking at direct emission or narrowband amber LEDs here. And so what defines these types of LEDs is multiple factors. First and foremost, these products have less than 1% light below 560 nanometers. Most of that light occurs between 520 and 560 nanometers. And that is just a function of how the LED is developed. And so even though it's not 0%, it is light that occurs naturally, and it is constrained in our spec. This aligns with Florida Wildlife Commission's keep it long requirement. We also require that these direct emission amber LEDs have a full width half maximum or bandwidth less than 20 nanometers, so they are narrow. That aligns with requirements for limiting spectral content below 560 as well. And we validate that that requirement is met independently by using pre-submission tools. So manufacturers that apply for the Luna turtle lighting product type will use the DLC Amber pre-submission tool, which is part of their dashboard. It's freely available. They'll upload a spectral data file called a SPDX file, and that data file is then analyzed to make sure that it has less than 1% light below 560. And only if it passes can that product sort of move forward to qualify for the turtle lighting product type. And so there is verification here. We also want to make sure that that spectral data is shared with end users. So as part of the Luna QPL, the SPDX file, the spectral digital data file, and the image of the spectrum, its distribution, is available on the QPL for free for tested products. And I will show you that in just a bit. Now, we also want to make sure that these products provide useful light. And so we do have a minimum light output requirement for all products. And that minimum is pretty low for area and roadway luminaires. It's 250 lumens. For wall-mounted luminaires, it's 250 lumens. And for bollards, it's 150 lumens. So we want to make sure that there is useful light provided by these products. We also want to make sure that the product is controllable. And so the product has to be continuously dimmable down to 20% of full light out of full power or less, excuse me. And we are reporting what sorts of controls options are available with it, what sort of driver is available, if there are sensors available, and I will show you what that controls options looks like on the QPL shortly. So you will see that with these listed product types. And finally, we want to support additional performance reporting that lets you understand what you are seeing on the QPL. And so there is supplemental performance data that we collect as well. Some of the data is not published, so we collect as part of our requirement process a safety certification and warranty materials. We want to make sure that they provide at least a 5-year warranty for these products. But we also, on the end user side, make sure that you can see the specification sheet and an image of the product so you can see what this looks like on the QPL. So there's some externally facing materials that are now available as well. Now let's look at the dedicated turtle lighting requirements that you will see on the QPL. And so we'll begin by looking at the distribution. Now, as I mentioned before, the key design principle for turtle lighting is it cannot just be about spectrum. We really need to look at multi-parameter control. And so we'll start by looking at distribution and then make sure we catch up with spectrum as well. So our distribution requirements are pretty robust, and these align with Florida Wildlife Commission's Keep It Shielded criteria. So first and foremost, we don't want these products to have any uplight. So they have a 0 uplight requirement. We do that by looking at the distribution requirements and making sure that they have a U rating of 0. We also want to constrain the high angle light. Turtles have a wide acceptance cone of view. They're looking laterally in the scene as they're trying to see find. And so we want to make sure we limit high angle light. And we do that by using the G rating. That's part of the bug rating system. Now, we're not looking at glare. We're not using it for glare. We're just using it because it is a convenient high angle distribution system that is commonly reported across manufacturers, commonly available in photometric software, and aligns well with Florida Wildlife Commission's Keep It Shielded criteria. And so for area and roadway luminaires, the maximum G rating we allow for turtle lighting luminaires is a G1. And for wall-mounted luminaires and bollards, the maximum G rating we allow is a G0, which is a pretty small amount of high angle light. That really ends up being the constraint on a lot of these products to make sure that we're not putting light in their acceptance cone of view. We also want to make sure the products are not tiltable in the field, because if you tilt a product, you can spill light onto the beach. So we make sure that the product either comes with a fixed or rigid arm mount, and or that if there is rotation available, that it's limited to a 10-degree tilt. And to make sure that that information is clear on the QPL, we make sure that the compliant mounting arm is actually part of that qualified model number or catalog number that you see on the QPL. For area and roadway luminaires, we want to make sure that there is a shield available. And so orbital shields have to be available as part of the spec sheet. It's part of the review process. You will see that on the spec sheets that are attached to the QPL or linked to the QPL as well. And then finally, we want to show you what the distribution looks like representatively. And so we take what we call the parent products or the tested products, and we show you the luminous intensity distribution, or what's called the polar plot, the way the light is distributed for each tested product. That is validated with a Luna pre-submission tool from their tested photometric files. So the testing and the QPL are linked, and you can see that image on the QPL, which we hope you'll find very helpful. It also shows you that there is no uplight and a limit on high angle light as well. Finally, let's talk about spectrum constraints. So as I mentioned before, direct emission amber LEDs are required. These have very, very little light below 560 nanometers, mostly again between 520 and 560. But we show you some additional information on the QPL. So the first thing we show is, does it meet Hawaii code? So Hawaii has 2 counties with some spectral requirements. And we show you how it aligns with those code requirements. Those are % blue and what's called traffic color compliance, where the color, the chromaticity or the color coordinates of the light source have to not be in the same space as a yellow traffic light. And so we show you that alignment. So you'll see % blue requirements and then traffic color compliance on the QPL. We also do not allow filtered LEDs to be listed for turtle lighting product types. So there's no white LEDs with an amber filter that is allowed for these product types. You have to use a direct emission amber LED. And that's to be sure that the filter cannot be removed or replaced or degraded in the future, and the spectrum changes. And so that's part of the application package, and it's validated with that Luna pre-submission tool. And then finally, our light output limits that we have for maximum light output. And here we again are trying to align with Florida Wildlife Commission's Keep It Low criteria. We do not have maximum mounting heights in our QPL. This is a luminaire specification, not an application specification. But what we do instead is we use the G rating and the maximum total lumens to constrain light output for these product types. And so we want to make sure that the light output is sufficient to meet safety requirements for human wayfinding and pedestrian movements and driver-pedestrian conflict that might occur. but we also want to make sure we're not overlighting. And so you will see that we use maximum lumens. For area and roadway luminaires, our maximum light output is 8,000 lumens. For wall-mounted luminaires, it's 2,500 lumens. And for bollards, it is 1,000 lumens, as you can see on the slide. And so all together, these form this comprehensive specification that allows you to have high quality lighting as well as metrics that are suitable for coastal environments where sea turtles are present. And so just to put this all together, I wanted to show how these are connected and that the turtle lighting requirements that are in place are certainly not arbitrary. They each target a conservation mechanism that can be defended in permitting and in procurement. So looking at energy efficiency first and thinking about the scale of the size and amount of products that are used in coastal communities. If our compliant luminaires are energy efficient, then local governments have an easier time adopting and maintaining this standard without creating an energy or a cost barrier. We do know that these are less efficient than white LEDs, so costs and energy use will increase certainly, but we're trying to find the most energy efficient products again within this category, knowing that we need to use this LED type. Next, by requiring direct emission amber LEDs and banning lensed white LEDs, we're protecting hatchling sea finding behavior by minimizing the short wavelength content that they are attracted to and eliminating the practical risk that filters will be removed or substituted over time. By requiring zero uplight and limits on high angle light, we're reducing sky glow and critically also reducing these bright inland horizon hues that are visible from the beach so that the sea turtle hatchlings maintain their sea finding behavior. And finally, by requiring that shields are available, having maximum light output caps and a maximum tilt angle or rigid mounting arm constraints, we're addressing this dominant failure mode that we see in the field, over illumination and beachward spill that disrupts both hatchling behaviors and adult nesting behaviors. And so let me show you a turtle lighting product on the QPL now. Let's see how I can do this graciously. Okay. All right, so you should be seeing the QPL. And so the QPL is free to use. You simply have to set up a free account and then you can find products. In this case, I have the turtle lighting filter activated, and I did that by going into Luna turtle lighting in amber, showing this little plus sign, and then clicking turtle lighting equals yes. We're just going to pick this top product. You are seeing a preview of the QPL that should be live to you in the next few days, where we have improved the aesthetics of the QPL, and we're showing a lot more of the controls categories and controls options. So you're seeing a preview of that today, rather than showing you what the sort of current QPL looks like that's going to be phased out any day now. I'm showing you the brand new preview. And so what you'll see here is the image of the product, its logos, the manufacturer, the brand, light output, wattage, the amber technology, direct emission amber is shown as DE amber. This primary use, which is our product type, this is a turtle lighting zero uplight pole or arm mounted area and roadway luminaire. It's product ID, and then you'll start to see controls options information as that is integrated in. So let me click on this and show you what this looks like. Here again, we see the product image. You can see that this is listed to SSL version 6.0 and Luna version 2.0 qualified. This shows you this is the current spec and it's shown in green. You can see the category. Again, it's a product type. The family code, if there's other products in this family, clicking on this link would take you to all of the products that are listed in the same family. It's low output general application type, how much light it emits. Whether this is a tested product, parent stands for tested product, so yes. When it was qualified, and then you start to see some performance information, its wattage, it's color rendition. We don't have color rendition requirements for amber LEDs, but we do require that their performance is reported. And that reporting allows you to understand exactly what the trade-offs are here in terms of color rendition. For direct emission amber, you're going to see these very low numbers or negative numbers. Basically, we have very poor color rendition performance under direct emission amber LED. As I mentioned before, that's one of the trade-offs of this product type. You'll also be able to click on the link to the specification sheet. So if you click on this, you'll get the specification sheet in your PDF browser, which I can show you in just a moment. Version history. So this product, if it was updated, you would see its version history. You start to see the version 6.0 controls. So in this case, you can see the controls option code. This is how the manufacturer lists its controls. This has a 10 volt, 0 to 10 volt wired driver with continuous dimming. It's dimmable down to 10%. It has no integral controls available. It does have a photocell available as an integral sensor, and it is not linked to an NLC listed, a DLC NLC listed network lighting control system. So you start to see some controls information about that. That will obviously vary by product type as the manufacturer designs the system. And then you will start to see all of this typical photometrics, electrical performance. I want to jump down here to the Luna Turtle Lighting Amber criteria. And this is what really differentiates Luna from other white LEDs. So first of all, we show you this SPDX file. That is the digital data file that I mentioned before. You can open that file in Excel or in an XML reader, and that shows you for each wavelength what the relative or absolute spectral power is. So you can see if it's narrow or broad. You can confirm that data independently. You can also find information about how it was tested, which is really important in a standardized file. You can see the percent blue, very little blue light here as expected. Traffic color compliance, this is basically just noise. It is traffic color compliant, so this would be acceptable in Hawaii jurisdictions, for example, in Maui or the Big Island. This would be an acceptable light source because it meets both of these requirements. You can see the spectral power distribution image and the luminous intensity distribution image, and I will show you those in just a moment. And then finally, this product also has some sustainability reporting. So you can see that this product is RoHS compliant. And you can print this page, save it to the list, send it off to a colleague, and start to see all of this information for the QPL. So let me just show you a couple more things. I'm going to show you the, this is the spectral power distribution image that you see. So you can see this is a narrow product. This is based on the tested data. It comes directly from the QPL. And you can also see the luminous intensity distribution image. This shows you the red line is the plan view of the light distribution. The blue line is the elevation view of the light distribution. And you can basically see that this is a forward directed light source with no uplight. And then let's go back and look at the rest of the slides. Okay. So now I want to talk about the application process. So how does a manufacturer get their product listed? How does it differ from our standard application process? If you're a manufacturer that is listed to the DLC with white LEDs, what does this look like for you? And the answer is there's some differences, but there's also a lot of similarities. So these products, just like white LEDs, are categorized either as a level 1 or as a level 2 product. So a level 1 product basically has one optic, only varies by dimming or voltage variations, obviously just has one spectrum, and it's essentially a single product. A level 2 application is a product that has multiple distributions, multiple light outputs, potentially multiple dimming and voltage variations, and essentially has all sorts of variations across performance, but is still constrained to direct emission amber LEDs. You can have an application where you have some products that are turtle lighting products because they meet the constraints, and other products perhaps that are just amber products and Luna, but are not turtle lighting products because they do not meet, for example, say, the G rating requirements, or they do not meet the maximum lumen requirements. So you can have a family that has both turtle lighting products and not turtle lighting products at the same time. That's fine. It just has to be clear to the reviewers how the family is organized. And the most important thing I want to mention here is that your testing has to be done on direct emission amber LEDs. It is not acceptable to use a white LED product, scale it to the light output or distribution of a direct emission amber product, and use that as a substitution. You will want to test your direct emission amber LED products within your product family submission package. And so you're going to need a minimum light output test with color rendition reporting. This is done with a sphere test with an LM79 color report. You're going to want to demonstrate that you meet our minimum luminaire efficacy requirements, again, with that LM79 color report. You're going to demonstrate that you meet our U rating and G rating requirements with LM79 distribution testing and LM79 distribution reports. And that will be conducted at the highest submitted light output for each unique optic. So if you are, say, submitting a type 3 model, you'll want to submit the highest light output product. That still meets the turtle lighting requirements and show us that the U rating and G ratings for that test still meet our criteria as part of your family package. And then finally, if we look at the application materials themselves, you will see sort of a summary of all the things you will need to submit as part of your application form. So you're going to have to give us an SSL version 6.0 and Luna version 2.0 application form. This has specific columns in it for Luna that you will fill in, and obviously PUD types for turtle lighting. You're going to want to submit a specification sheet. You're going to want to give us your LED package, your LM80 data and specification sheets, all of your test data, all of your test reports that show that you've done the required testing for the products that need testing. You're going to want to give us any supplemental power quality test reports. If that's not part of your LM79 primary testing, that supplemental data is still required. We'll need your photometric files. We'll need your SPDX files, your spectral data distribution files. You will have image files from the DLC Amber and Luna pre-submission tools you'll have to submit, and we'll be checking that those constraints are met with our reviewers. We'll need your warranty documentation, your proof of safety certifications as a PDF, and all of your lumen maintenance and color maintenance testing information, including your ISTMT testing, your in situ temperature measurement testing, LM80 testing, and your TM21 calculators. So all of that is pretty similar to what you would do for white LEDs. We're just looking at it for amber LEDs here. And as you can imagine, the requirements for amber LEDs are slightly different than white LEDs. For example, the L70 is, I think it's 36,000 hours instead of 50,000 hours because that is how the data should look and what the data shows us we should get for these type of LEDs. Okay, so here's my references. First and foremost, you should use the technical requirements as your primary reference source. We're always available for questions. You can meet with our team if you'd like to have a meeting before you submit to talk about what optimum testing plans look like. We'd be happy to do that with you for Luna. But the primary reference is there, and then all of these documents that you see here I used in my background information that show how electric light affects sea turtles. And now I am happy to answer any questions that might exist. So I think what I'll do is I'll stop sharing and go to Andrew.
Great. Yeah, fantastic job, Leora.
Thank you.
You were quite thorough, so not a lot of questions came in during your presentation, but I'm getting a bunch now, so that's
Okay,
great.
great.
One thing I'll just answer quickly right off the bat, I had a basic kind of lingo question. So QPL stands for Qualified Products List,
Oh, thank you.
for anyone that doesn't know.
Yes.
But now to the ones that are definitely need an expert. All right. So Leora, what is your take on Hawaii's requirement for CIE 1931 color spectrum for traffic signal spectrum for lights when most lights are shielded and bug rating U0? Does this affect the narrow beam amber?
And that's an interesting question. So I think what they're asking here is I think what they're asking is it confusing to sort of see amber streetlights in your field of view and see yellow traffic lights in your field of view, and maybe you're confused by seeing those at the same time, given how products are shielded. I'm not sure. I do know that I was on the Big Island a few months ago for a turtle lighting symposium, and certainly not all of the lights were shielded. There's a lot of yellow street lights that you can see that actually are sometimes the same color as the yellow traffic lights, and it does create a lot of visual noise in the field. I don't have any studies that show whether or not it's confusing or not, so I can't answer that. I'm not sure that it's important, but I do know that if the spec is not comprehensive, then perhaps visual noise can be confusing to drivers and pedestrians trying to understand what to do in a complicated roadway environment.
Great.
So
Yeah. And the question was
not a
for
good
your
answer. Yeah.
take. It seemed like a pretty shop talk question.
Yeah. So my take is I'm not sure if it's that important, but the reality is it's part of the spec. So we want to make sure we make it easy to meet. Um, yeah. There's interesting lighting on the Big Island with regards to spectrally selective light for sure. It's not just spectrally selective. Sometimes it's too much, sometimes it's too little. Um, it's an interesting environment to be in.
Well, here's a softball question for you. Do the
Okay,
distribution requirements apply before the available shields are attached or after?
before. Yes, so these are the baseline requirements. So every turtle lighting product has to be U0 and have that corresponding G rating even without the shield. So shields essentially allow you to, the way I think about shields is they allow you to um, resolve geometry issues that occur in the field. So for example, that beach I mentioned in Hawaii, Sandy Beach on Oahu, the parking lot is high above the water line. So basically you're sloping down towards the beach. A shield is going to protect that light from sloping down and hitting the beach, but it isn't going to have as much an effect if the beach was flat. So you want to make sure that the distribution is appropriate. Now, I will say that in many ordinances, the orientation of the light source needs to be away from the beach. You need to face it inland. That's not something that, for example, a Luna spec could apply because, again, this is a luminaire spec and not an application spec. But it makes sense from a beach perspective that you want to make sure that the rear of the luminaire is facing outwards towards the water. And if you need house side shielding to make the beach darker, that can happen. I seem to have frozen.
We can hear you.
Wait, okay.
It looks like maybe your camera is struggling, but we can certainly hear you.
Yeah, I'll turn my camera off for a moment. See if that helps. What an
Good
unfortunate
idea.
photo.
Well,
Try
I'm in the
again.
spotlight now.
Yeah,
Well, we have another question for you.
okay.
Will recessed downlights ever become part of the DLC scope for Luna or turtle friendly lights?
Um, I would say at this point, we do not anticipate having downlights in SSL or Luna. I think if there's a very specific use case, say for direct emission amber LED downlights to be included, we might look at that very narrow use case perhaps, but at this point, it's not in our roadmap.
Thank you, Leora.
You are welcome. Seem to have lost my camera, so hopefully you can hear me just fine.
We can certainly hear you. Yep.
Thank you.
Well, here's a question about shields. Someone is wondering if they can have more details about shields, whether it should shield the visibility of the glowing lens from the beach. So I think it's about shield sides.
Yeah, that's a really good question. So um, I think there's some really innovative shield choices that I've seen in some products where you can almost think about the shield as like a Lego, kind of where the shield can be shorter or longer, and you can basically specify the height so that you do actually address that specific geometric concern you have on your beach. I've seen some manufacturers offer that. I think it's a really clever and interesting technique, and maybe it's something that snaps off in the field or is easily modifiable in the field. Um, but other manufacturers might just have one shield available in their spec sheet. And in that case, I think the best policy or the best way forward is to do photometric layouts with that shield in place. So ask for shielded photometry. We actually make an allowance in our efficacy criteria for shielded photometry on the QPL. We would love to see that. But ask for shielded photometry and then model your layout and figure out if that shield is effective or not, because you might need to ask the manufacturer to do something more customized to really block the light from hitting that beach. That's what we want to do in this situation.
So in speaking of lighting designs, we have someone wondering if any municipalities or jurisdictions have adopted or mandated Luna turtle listing. And in this situation, if it happened, would a QPL listing bypass local approval requirements and product listing?
Oh, those are good questions. So we have seen Luna adopted into some jurisdictions as recommendations into some ordinances, not yet for turtle. I would say that Luna is not intended to replace jurisdiction requirements. It's intended to support jurisdiction's ability to have good quality lighting. So we don't intend that to replace review. Again, there's a lot of application requirements that have to happen. You want to make sure the lights are oriented correctly, the mounting heights are correct. There's no way with a single luminaire to sort of imagine all of the geometric options that occur, right, with a beach. How close is it to that dune line? How close is it to the edge of the parking lot? Is the beach sloping up or sloping down? Is there vegetation in the way that's blocking the luminaire? You really have to look at each site specifically. And in that case, that jurisdiction authority probably has some sort of requirement for photometric plans, some additional requirements that have the specifier demonstrate that there really is no light on the beach. And that extends beyond what Luna can provide. What Luna does is it supports that the light source itself has the right spectrum, provides the right amount of light, provides this type of optic, has this controllability factor, is energy efficient, but the rest of it really also has to be looked at photometrically. And that's where the installation and verification part continues to occur. And so we hope that that jurisdiction has some sort of process that they use with photometric plans to ensure that the light is installed correctly, because you could have a very high quality light, and if you imagine if you install it upside down, it's now a terrible light, right? So you need to have some sort of pragmatic review process as well, in addition to a qualified products list that makes this work.
Thank you. So we have some very interested people. We've got a great yes and question. Are
Okay.
you working on specs for other species?
Um, not at this, well, not directly at this time. We are involved in some really exciting research on seabirds, but nothing at this point that would lead to a spec. So at this point, we've been really fortunate to get to work with the folks at Florida Wildlife Commission and with Luke Davis from U.S. Fish and Wildlife, for example, to help make sure that our spec meets their criteria, meets their intentions, and is aligned with what they're doing. Because it's those ecologists that are really the subject matter experts in what turtles need. We're able to partner and work with these folks as lighting experts in making sure that the lighting product complies, but we really work closely with ecologists to understand what they need in terms of performance from these lighting systems.
Thank
I
you.
I will just
Oh,
add that I would
yep.
not use direct emission amber sort of as a blanket fill product for every species for a number of reasons. One is, there are some species that are sensitive to amber light. The one that comes to mind quickly is fireflies, where that sort of light color creates confusion in that application. Amber, these narrowband amber, direct emission amber LEDs are also not as energy efficient. And so tripling our power use just because we think something will be better without clear evidence that it's needed is not a good solution for our planet, for our species, for the world, for our power bills. And so I would be very careful just using direct emission amber as a default solution everywhere. It's likely not needed, and there are important trade-offs between light levels or irradiance and spectrum that have to be considered as well.
We have actually we have a couple questions that pertain to sort of the long term uh, considerations when installing these LEDs. And first, I want to mention that we do have an attendee that is sharing some great additional research, and we have this attendee asking if we're aware of any research that shows benefits to sea turtles using uh, yellow or red spectrum on the LEDs long term following the installation. Um, let's see. Specifically more about a review before and after the turtle lighting is installed. So maybe some of these other attendees have that as well. So not sure if you can answer off the cuff, Leora.
I think I'd have to see the question a little bit more. There's some of the turtle research that showed that red was also, all else being equal, not as visible to behavior or disorientation as as amber. I think from our perspective, the question with red is multifold. One is obviously we'd want to look at the energy efficiency, lumen maintenance, color maintenance capabilities of that product, those products, make sure that we have a spec that supports those products. That's the one side of it. The other side of it is I am not sure just how much they improve visibility compared to amber. We want people to be in these environments with these LEDs. And if you can have amber LEDs that are shielded, low light level, don't interfere with hatchling orientation, and still provide wayfinding and pedestrian support for humans, then that might be sufficient versus trying to do something that maybe is a little bit harder for humans to see under and maybe creates more of a conflict. So I think I need to do a little bit more analysis, but it's not directly a limit, I would say, more so some practical limitations we found as we were developing the spec. But I will I will read the questions more fully and get back to this questioner. So thank you.
Yeah, good point. We do get all these questions delivered to us after the webinar and all your contact information so we can follow up.
Yeah. So I will definitely follow up. I
Yeah.
can see who it is. So off the top of my head, I think it's a matter of alignment, I would say, alignment with
Mhm.
technical requirements and alignment with human vision. But
And
good questions.
we have another question that you might not be able to answer off the cuff, but I think it's interesting. It shows where people's heads are at. This person says, I have seen where the yellow coating on LEDs has burned off due to high heat over time. How do we address that issue? So maybe not exactly this webinar, but something to consider for the future, perhaps.
Yes, yeah, I think we'd have to, that is a really good point. I think we'd have to look at the details of that and what they mean. Certainly, LED testing, lumen maintenance testing, and color maintenance is part of the DLC inputs and part of our specification underpinning the turtle lighting spec. But if they're talking specifically about filter performance, degrading, or if they're talking about sort of this yellow coating on bug lamps degrading, I'm not sure what they mean. Neither of those things is allowed for turtle lighting LEDs, I can say that, but to get into the details of that, I'd have to understand more, and we'd have to start looking at some data sets.
Sure. So I think we have a few other questions, but I think they're best for following up. So if we didn't get to your question, we will definitely follow up after the
Terrific.
webinar. Yeah.
Thank you. There's some excellent questions in here. Yeah, I think I'll definitely follow up with these attendees directly, and maybe there's ability to collaborate or an ability to have some follow-up information from subject matter experts on this on these questions. At this point, just sort of off the top of my head, I don't have anything to offer.
All right. Well, one last question before we go. Leora, what is your favorite color?
That is a funny question. I would say it's orange. Which is that amber? That's my question. Is orange and amber the same color? We'll have to ask a large group of people and find out. Thank you, everyone, for attending. I hope this answered your questions. I'm going to put my email. Let me just put my email in the chat. And that chat should be available to everyone. So you may follow up with me directly. Thank you for your excellent questions and your time today. I appreciate too, we delayed this, this webinar by 1 week from last week because I was a bit under the weather. So thank you for attending today. And please follow up. I'd love to have conversations with you about this. So there is my contact information. And thank you, Andrew, for doing such an excellent job with the questions and answering everyone in a timely manner. Thank you to Lauren for hosting. And thank you all for being part of our stakeholders. We appreciate your collaboration, and we hope to work with you on this topic.
Thank you.
Thank you. Bye, everyone.